Welcome back. This is Module 8 of the Introduction to Java Programming for FRC. This module covers documentation. I thought long and hard about where to put this module in the course because documentation is one of the most important things in Java programming, in any programming, not just Java. Java has a fairly mature system of documentation called Javadoc, and I encourage you to become familiar with it and to use it. So why would you bother with documentation? I've heard the phrase over and over from professional programmers, well, the code is self-documenting. The problem I have with that is when you're just learning the language and you don't understand the nuances of some of the structures of code, it may not be self-documenting, or rather, it may not be obvious to someone who's just learning the language. Another issue is it's not uncommon on an FRC team to have multiple programmers working on the same module of code, whether it's a class or a method or the entire robot. And you really want to be able to integrate your code together, which means it's vitally important that everyone on the programming team understand what every attribute and what every method is there for and what its purpose is. I've seen a number of times where team members who mean well have gone in and added some new methods because they think the robot needs them. And we find later on that now there's 2, or in one case even 3 or 4 instances of the exact same method that are implemented slightly differently. And that makes it really, really difficult to debug. So if you engage in a rigorous discipline of documenting your code, it'll become A, much easier to understand, and B, it'll be much easier to share your design of your code with your mentor or with your instructor or your coach, who may not be a programming professional. So code comments are the core of Java documentation. They're probably one of the most important parts of useful code. They should describe in English, or whatever your primary language is, what the code is trying to do. So you're not explaining it in Java or in pseudocode. You're actually describing it in English. What is the role of this piece of code within the larger system? Why does this piece of code exist? What is important about it? If you can't explain why it exists or what its role is, you shouldn't have it. It's that simple. Every Java file has a class, because in Java everything is a class. So every class should start with a comment, and every attribute within the class should start with a comment, and every method within a class should include a comment. And that includes enum values within an enum class. Those are attributes, and those should be commented. For attributes, the comment should include the range of values. It's pretty simple to say, declare an attribute double setPoint, and you'd read that as setPoint is a double. That's fine, but what does that mean? Oftentimes in the FRC library, things like motor output, joystick values, and those kinds of things are stored as doubles, and frequently they're in the range of -1 to +1, where +1 is equivalent to 100% forward power, 0 would be off, and -1.0 would be 100% reverse power for a motor. Or on a joystick, 1.0 would be pulling the joystick fully to the right, and -1.0 would be pulling the joystick fully to the left, and 0 would be the joystick is in the center, not pulled in either direction. So that's a common range that we run into over and over again, but it's not the only range. A lot of times when you start getting into vision processing or using gyroscopes or using other sensors, we have different ranges. So that's why it's important in your comment for your attributes to describe what is the range of valid values that this attribute can hold. For methods, we want to describe what the purpose of the method is, but we also want to describe each and every attribute and the return type if it's non-void. For each one of those parameters, we also want to describe its range of values. For Boolean, that's pretty obvious. The range is predefined. It's true or false. But for any other value, we want to describe what it means. So let's look at the different comment styles in Java. You've seen most of these already in the slides in modules 1 through 7. So a full line comment starts with a // no spaces between the slashes. What the compiler treats that as, everything after the double slashes is ignored until the end of the line, which means you have to put / on every single line for a multiple line comment, which is fine. That's just the rule. There's a multi-line comment which has a beginning tag and an ending tag. The beginning tag is /splat. Splat is a short for asterisk. And the ending tag is //. And those can be placed anywhere in the code. When the compiler sees a /splat, it will ignore everything until it sees a // which could be on a different line. It could be on the end of the current line. Javadoc has a special form of the multi-line comment. Javadoc start with /splat. And what that tells the compiler is that the contents of the tag should be treated by the Javadoc processor. When you run the Javadoc processor, it's going to actually process the comments between the beginning and ending multi-line comment tag and convert that into HTML, which you can then either upload to a website or you can share with other members of the team. It's pretty important as a programmer that you communicate well with the other teams. I know on the teams that I've coached, we've had a chassis and drive team, we've had an electrical team, we usually have a game mechanism team, and occasionally the game mechanism team will be broken up into sub-teams. We'll have a loader team and a shooter team. Each one of those teams is working on their own mechanism with their own control system. And it's vitally important as a programmer that you understand how that works. So having an ability to output some of your description in English of what the code is supposed to do and how it works will be vital to sharing that with the other members of your team. Javadoc is part of the JDK. So when you download the Java JDK, you've already got it. And the Javadoc processor generates standard format HTML from Java source files. Some other tools, such as UML editors, also produce Javadoc formatted HTML as well. So it's become, for all practical purposes, a universal standard. Everyone does it in the Java programming profession. And you find that other languages are starting to incorporate Javadoc-inspired features into their standards as well. Almost all Java libraries publish their documentation in Javadoc HTML pages, including FRC itself. So the Java library for FRC is the Worcester Polytechnic Institute FRC Java library, and we call it WPI LibJ for short. WPI is Worcester Polytechnic Institute, Lib is library, J is for Java. So when you go to the WPI LibJ documentation site, what you're looking at is the HTML generated by the Javadoc processor itself. So no humans have had to go in and hand edit this HTML. The humans work in the Java development environment writing the code, and the Javadoc is produced automatically. And this last bullet is important. You always want to write the Javadoc first. So before you write a line of code, you want to explain what your code is supposed to do. And this is not just for FRC. This is anytime you write code. So here's a screenshot of what the Javadoc HTML page looks like for the WPI LibJ. This specifically is the CAN Jaguar HTML page. Now I'm going to flip over to a web browser and navigate through the WPI LibJ so you can see some of its features. So I'm searching for WPI LibJ Javadoc. And the first link that I found is at wpi.edu, FRC RoboRio Release Javadoc Java. So when I click on that link, I'm now looking at the live Javadoc HTML pages from the WPI site. Up in the upper left corner, I have a frame that shows me all the packages that make up this library. And you can also see the start page is also all of the packages that make up this library. Then in the lower left frame, I have all the classes in the entire library. So anything you want to know is here. So I'm going to pick one. How about sample robot? So when I click on that link, I am now taken to class sample robot. I can see its inheritance hierarchy. It starts inheriting from java.lang.object. Every class in Java inherits from java.lang.object. Then derived from object is robot base, which is edu.wpi.first.wpi.libj.robotbase. And then, lastly, we come to sample robot, which is also in the package edu.wpi.first.wpi.libj. We can see its declaration in the next section. It extends robot base. Extends is the Java keyword for inheritance. Here is the actual Java documentation converted to HTML from the class itself. So it tells you it's a simple robot-based class that knows the standard FRC competition states, disabled, autonomous, or operator controlled. It has a field summary, which are all the attributes. Then it has a constructor summary. The sample robot class only has a single constructor, a default constructor that does not take any parameters. And here is the Javadoc comment that was typed in for it. Creates a new sample robot. Then we have a block of HTML that shows all of the methods. There aren't a lot of methods for this class. There's 1, 2, 3, 4, 5, 6, 7 methods. Autonomous, disabled, operator control, robot init, robot main, start competition, and test. You can see the return type for each one of those methods and its access specifier. And you can see the high-level description for each one of those methods. So if I look at the autonomous, its high-level description, autonomous should go here. If I click on the link, it actually takes me to the full Javadoc. And you can see by the scroll bar, it's scrolled down towards the bottom of this particular HTML page. Autonomous code should go here. Users should add autonomous code to this method that should run while the field is in the autonomous period. FRC seasons start each competition with a 15-second autonomous period. If this method is only called once, that means we're going to have some kind of loop inside of our autonomous method that iterates through the behavior that the robot exhibits during that 15 seconds. Operator control, which is the next method down, is described similarly, called once each time the robot enters the operator controlled state. If we have a 2-minute 15-second operator controlled state, again, we know we're going to have some kind of loop inside of our operator control method. Remember that sample robot is derived from robot base. Robot base has some methods that we inherit. So these are some things that we get for free. These are built into a different class, robot base, but we can still use them. Those methods are is autonomous, is disabled, is enabled, is new data available, is operator control. We know that if a method starts with the word is, it is a Boolean method. So we can be pretty darn sure these are going to return Boolean. There's another important one here I want to show you. Main. When you run a Java program, it will invoke the main method of the class you specify. I'm going to click on this link and we're going to go into the robot base. And we can see main is a public static void main that takes a variable number of string arguments. So that's why in FRC we do not actually have to create a main method for. This is abstraction. The people who built the first competition know that every robot is going to have to execute, so they put that main method in robot base. So robot base.main is called automatically when your robot boots up when it's configured in Java mode. Once that code is running, that code is going to do all the common behavior that's been abstracted out of your individual classes into a higher level generic class. So that code is going to be communicating with the field management system, registering the team number, and handling any methods like autonomous, operator control, and so on. How does it do that? That's polymorphism. The field management system knows to invoke, to send a packet to your robot, and the main code in your robot knows to invoke either the autonomous or the operator control method. So hopefully you're starting to see all of those principles coming together: encapsulation, abstraction, inheritance, and polymorphism. Right here in this one class, sample robot, we've seen all four of those principles of object-oriented programming. There's also some methods we've inherited from the object class, java.lang.object. Remember, I said every single class in Java has an equals method. Here it is, equals. It also has a clone, which are mostly deprecated. We don't use clone much anymore. It has a finalize, get class, hash code, notify, notify all, toString, and a couple different variants of the wait method. So every single class in the FRC library has Javadoc like this. And I don't want you to freak out. You don't have to know every single one of these classes like the back of your hand. But there's a couple of them that you are going to learn. And the next course that I'm going to teach, the FRC course, is going to go into some of these classes in more detail and how you take what you've learned in this introduction course and apply it to build a complete robot that can compete in the FRC competition. So here's some of those classes. There's Joystick. Obviously, you need to receive input from something, and the joystick is the most common way. You'll use driver station. You'll use the various bits of hardware that the FRC kit of parts gives you. So I'm going to look at one of those motor controllers, Talon SRX. So we can look at its inheritance hierarchy. It again starts at object. It goes to sensor base because this motor controller can provide sensor data. Then it implements PWM and safe PWM because it can be accessed on the pulse width modulation bus, PWM bus. And then lastly, it implements PWM speed controller and then Talon SRX. So if we look at it, it has one constructor that takes a channel number. This is for a Talon SRX connected via PWM. If we look at its methods that it inherits from speed controller, get inverted, PID write, set inverted, then it includes methods from safe PWM, including disable, is safety enabled, is alive. Then we have PWM, which includes methods like get position, get smart dashboard type, get speed. It also has set disabled, set position, set speed, and we know any method that starts with get is a getter, and any method that starts with set is a setter. So that's implementing encapsulation. Then we have methods inherited from sensor base that includes check analog output channel, check PWM channel, check solenoid, get default solenoid module. So these are some methods to let it integrate with other pieces of hardware in your FRC library. And lastly, from object, it picks up clone, it picks up equals, it picks up toString. And from speed controller, we picked up disable and stop motor. So you can see this is a much more complicated class. Hopefully, you've seen that when you use discipline to fill out your Javadoc comments in your Java code, you can create your own Javadoc web page that describes the behavior and the functions of your robot to anyone else who might want to know. And that could be anyone on your team, including your coaches and your mentors. It could also be students in FRC competitions in years to come. Because if you publicly share your code, not only are you helping your own team, you're helping other teams and you're helping students who come along later who have seen your robot either in YouTube videos or in person at competitions and are amazed by what you were able to accomplish and want to see how you did it. So Javadoc is a crucial aspect of writing good, sound Java code. So what does Javadoc look like? So let's look at a Javadoc example. This is an example class called ARM. Right at the top, we can have Javadoc comments for the entire module. This is for the entire class and everything in the module. We have its package statement, its import statement, Then we have the class Javadoc comment. This is the declaration for the class. So when you look at your HTML that's generated, this is placed just below the module comments. Then for every attribute in the class, we put a comment at the beginning of that attribute. Remember earlier I stated we always want to declare one attribute per line, so we can put a line above it that has the Javadoc comment. If it doesn't fit in one line, that's fine. These Javadoc comments are multi-line comments, so you can span it. So you can see by tradition, I usually align the asterisks in our multi-line comments. If it's a single line, I put the open and close on the same line. Then for the constructor, we have a comment for that particular method. So every method has its own comment. Usually method comments are always multi-line, even if they're very simple. But as we'll see in the next few slides, they usually have more information, which is why they're usually multi-line. So Javadoc provides tags that uniformly format important elements. The proper use of tags is a must. So just like annotations in the Java language, Javadoc tags are an @ symbol followed by a lowercase word, for example, @param or @return. Javadoc allows you to use HTML tags in the comment. I would advise you though, the Javadoc processor is going to be converting your comments into HTML for you. So use HTML sparingly. You don't want to make this too creative. The point of Javadoc is uniformity, so that anyone who knows Javadoc can not only understand your documentation, but also the WPI LibJ documentation and the Cross the Road Electronics documentation and anyone else who provides Java documentation. So any Java keyword in your Javadoc comments, it's okay to put those in code tags. In HTML, a code tag starts with less than code greater than and ends with less than / code greater than. You can also, if you have bulleted lists, use the UL tag, the list item tag, and the end UL tag. UL is unordered list. Make clear what is required in your class and what is allowed to vary. Things that are not allowed to vary are constants. In Java, those are invariants. They do not vary. So you also want to make clear what is required. If you take a parameter that is a object reference, is it allowed to be null? If you take a channel number, like a CAN ID or a PWM channel or a relay channel, is it in the range 0 to 8, 0 to 63? Do you allow negative numbers? What do the values mean? So let's look at the important Javadoc tags. There's probably 40 or 50 tags defined, but we're not going to use all of them in our FRC programming. Some of the more important ones, @author, that adds an author block into the HTML. Usually you put that in your class comment. It's critical if you have multi-developer programs. If you have a game mech class where one programmer is doing 3 methods and another programmer is doing 4 methods, you probably want to put the author tag on each method so you know who's responsible for or who did write each method. There's also an @version tag. If you're tracking versions in your code, you can add an @version. So you can put information like, this is for the off-season competition, or this is for the district competition, or this is for the regional final. @param is required for every single parameter. You need both the parameter name followed by a description of what the parameter means. That includes what values is it allowed to take and the range of those values. @return is required for every non-void method. It adds a return section into the HTML that's generated with the return type and a description text. @throws adds a throws subheading to the generated HTML with a class name and a description of that class. So if you have a class that's going to throw an invalid argument exception or a null pointer exception, put @throws in your Javadoc. Occasionally, you're going to see @deprecated in the WPI LibJ. When you see that, that means they've changed to a different kind of method, and you really shouldn't use the old style anymore. It's still in there, You can still use it, but you have to understand anytime you apply an update to the FRC plugins, that method may go away. So just be aware, if it says add deprecated, use at your own risk. @C is for referring to another method's Javadoc. Most often you're going to see this when methods are inherited. If you're inheriting the operator control method, you probably want to write your own documentation explaining how your operator control method is going to work. How does it use the joysticks? How does it use the buttons on the joystick? But there are some cases where you're not changing the behavior of the method. You're just implementing the behavior that's already been documented. Most often this is the case for interfaces. And there's a couple of commonly used interfaces sprinkled throughout the FRC library. So in those cases, it's safe to use the @C and just refer to Javadoc that someone else has already written for you. So here's an @author example. This is a class arm, and we put in English what that class does. It defines an arm for the sample game. The arm has a fixed tower with a 4-bar linkage that pivots at the shoulder and wrist joints. The gripper is held facing down, parallel to the floor at all times. The arm can be raised and lowered. The arm is composed of a gripper that can be turned on to pick up a ball and off to release a ball, and has a sensor to detect when a ball is held. And I put in there @author Tom Dunn. So anyone who's looking at this documentation knows to go ask Tom Dunn if they have questions about this class. So here's some examples of the @return and @param. So I have a method in my arm class isDown that returns Boolean. So I put in my comment, determine if the Talon SRX reverse limit switch is tripped, @return Boolean. That's the type. You always put @return and the type, and then your comment. True if the arm is all the way down, false otherwise. For @param, I have a method setShoulder that takes a parameter power. So my comment is, sets the Talon SRX motor controller power set point for the shoulder joint. Note, motor will continue to run after this method exits. So when this method is invoked, it turns on the motor and then it exits the method. We have to do that so the method returns back to the code that's checking for joysticks or buttons or sensors or things like that. For our parameter, power, we put in @param and then the name of the parameter, power. It's a power set point in the range of -1 to 0 to +1.0. So that's important. Always include the range for values, for parameter values. It's pretty straightforward to write the Javadoc in your methods as you're writing the methods. More correctly, write the Javadoc before you write your methods. Many of the Java IDEs will create the Javadoc for you. So for example, if I put in public boolean isDown, open curly brace, and hit enter, a lot of Java IDEs will automatically put in the closed curly brace. When I then go up and type in /splat and hit enter, IDE will pre-populate your Javadoc comment with the correct @return and @param tags. So a lot of the work is done for you. A lot of the grunt work, the formatting, making it look pretty. What you have to do is actually fill in the body of the Javadoc. Thanks for attending this course. I've had a good time putting it together. Hopefully you found this course valuable and you've enjoyed this YouTube delivery format. This delivery format was chosen to allow you to go through this courseware at your own pace as your schedule permits, but it's also designed to give you an opportunity to go back and look at the Java tutorials and follow along in the tutorials as you go over these modules. This is just a very brief introduction. There's a lot of aspects of Java programming that I did not cover because they're a little bit outside the scope of FRC programming, or they're outside the scope of just a quick introduction. So hopefully this has amplified the interest in programming you already have, because of course everybody has an interest in programming, and it'll lay the groundwork for you to go into the next class, the FRC programming class. Thanks for attending.